So we know from our given pair that we have gone out 40, a radius of 40, and we're at our terminal side. Theta is 30 degrees. So if we draw that out and we complete our right triangle, we have a triangle here in that quadrant 1. Okay, so I want to convert those back to my x and y, right? So I'm going to find those using my ratios, okay? For starters, I'm going to start with the cosine of 30 degrees. So if I did cosine of 30 degrees, what would that equal? What's the ratio? What over what? And adjacent in this case is the x over the hypotenuse of 40. Okay? So x over my radius of 40. Okay? But if I want x, all I really need to do is solve for x, right? So how could I solve for x? Multiply both sides by 40. Okay? So those would cancel, so I would have x equal to 40 times cosine of 30. What is cosine of 30 off of your unit circle? Square root of 3 over 2. Okay? So 40 we'll put over 1. So 40 times 3 square root of 2 would equal what? Forty times the square root of 3 over 2. Over 2. And can we do some reducing? And what would it end up being? 20 square root of 3. So that's your x. Okay. Now let's take the sine of 30. So the sine of 30, what would your ratio be for that one? Opposite over hypotenuse, or we would say what? What over what? Y over the 40. So we could do the same thing here, multiply both sides by 40. So we would have 40 times sine of 30. What's sine of 30? 1/2. And 40 times a half would be 20. So we would get 20 equals our x. Equals our y. So we can change our 40 radius 30 degrees theta into our x and y, which would be 20 square root of 3, comma, 20. Okay? So let's come back here and let's get some pretty much general here. So in both cases, we multiplied the radius, right? We multiplied the radius times the cosine, and we multiplied the radius times the sine. And in both cases, we used our theta of 30. So in general terms, we could, in fact, say, okay, if I want to find my x is going to be equal to my radius times my cosine of what? Of theta. And for my y, if that is going to be my radius times my sine of theta. Okay. So for 20 and 60 degrees, we would be right here. So your theta is the 60 and your radius of 20. So let's use our formulas here. X will be equal to the r cosine theta. So x would be equal to 20 times cosine of 60. So that would be 20 times, what's your cosine of 60? 1/2. And then when we multiply those together, we get what? 10, okay? So there's our x. Now our y equals the r times the sine of theta. So that would be y equal to 20 times sine of 60, or 20 times, what's the sine of 60? square root of 3 over 2, and that would be 10 square root of 3. So you would have 10 comma 10 square root of 3. So you would be 10 miles east and 10 times the square root of 3 miles north, right? So you'd go east and then you would go north, and that's your ordered pair, okay? And let's do our last one, see if we can get that in for the bell rings here. Yeah, we can get it in. All right, so 40 and 150, I think we're over here in quadrant 2. Okay, so if we're doing that, what is our reference angle? Or actually, we know those. What's our 150? So we're going to do r, let's do x first, r times the cosine of theta. So the radius in this case, let's label. If we're here at 150, if this is 150, what's our little reference angle? If from here to here is 150, what's our reference angle? 30. Okay. So we have 40 times our cosine of 30. Cosine of 30 is square root of 3 over 2. Or what?
20.
Okay, 20 square root of 3. Now, we are in quadrant 2. What is your value of x in quadrant 2? Negative. So you have to make sure that you have, actually, I think I did, this was negative up here, wasn't it? So we'll carry that over. And then real quick, our y is r times our sine of theta. So again, 40 times your sine of theta. 1/2. Would just be what? 20. So your ordered pair in xy is your 20 square root of 3, comma 20. All right? Any questions on those?
Hello, Patriots. If you are planning on...
Yes, that is negative 20 square root of 3. Thank you.